analysis means you have an amplifier, and you're applying some VCC here. Of course, gain cannot be greater than your biasing. And then you have an input terminals, you have an output terminals. You can put it a resistance RL here, and you are say you have some source here. You have some source, AC source VS, with an internal resistance RS. So far, what we were doing when we were putting the source, we were not considering this RS. So sometime with source, the internal resistance of source will be also connected. Internal resistance of source. So whenever this kind of circuit comes, you encounter, you don't bother anything, because finally my V input will be measured here. My V input will be measured here. Some drop will be here because of internal resistance of the source, but that I don't that will not affect my formulas. Okay, because my V input is here. I'm measuring the V output here. So I will show you one example, and then we'll practice some questions of amplifier, and then we'll go to the next topic, operational amplifier. So let me start with a say voltage divider circuit. Okay. So I'm giving an example, say a voltage divider circuit. So you have a op-amp, transistor. You have a RC. You're applying some VCC, and here you have R1, R2, RE, and then you have a here you have a capacitor C1, and then you have here a resistance RS, and then you have some source VS here. And if you have a capacitor here C3, you have a capacitor here C2, and here I'm measuring the V naught. If you want, you can put a resistance RL also here. If you want, you put resistance RL also here, and you are measuring V naught here. Okay, this is your circuit. This is your C1, this is C2, C3, and now the values are given. Values are given, say VCC is 12 volt, R1 is 90 kilo ohm, 90, R2 is 22 kilo ohm, okay, beta is given 100, and say RE is 1 kilo ohm, 1 kilo, you take 1.5 kilo, RE is 1.5 kilo ohm, okay. This is your RC is your 5 kilo, RL is 1 kilo, RS is 1 kilo. Now I want to calculate the input resistance, voltage gain. Okay, RE is, check what is the value of 1.5 kilo. So this is my circuit. I want to find the internal resistance, output resistance, voltage gain and current gain for this circuit. Okay, let us calculate. So first thing is what? First thing we will do the DC analysis. Okay, because we need to find the RE. Okay, so the first thing will be DC analysis. That means calculate RE. Okay, so for DC analysis, what will happen? Your capacitor will be open circuited. So I will remove this one. This portion will be removed. This capacitor will be removed. Now this is my DC analysis. Okay. Now this is a simple voltage divider circuit. Okay. Now what should I do? Tell me. So if I multiply this by 100, beta RE means beta RE should be greater than equal to what? 10 R2. Is that the formula condition for approximation? Tell me, Karishma. It is the condition to solve the voltage divider circuit by voltage by approximation method. See, you can use approximation method, you can use the accurate method, that is a choice. But I will generally choose approximation method. Okay, it will be almost equivalent. Okay, so here also if you 1.5 into 100, this becomes 150 kilo ohm. How much? 150 kilo ohm, and this is 10 R2, this is 220 kilo ohm. So beta RE is greater than 10 R2, or 10 R2 is greater than beta RE. What is the condition of approximation? Tell me, Deepak. What is the condition? Tell me. Okay, whatever the condition. Okay, I am going to solve this with the approximation method. You can solve with this one, with accurate method. Answer में ज़्यादा change नहीं आएगा. So I want to solve with this approximation method. That means I need to find the VB. Okay, approximation method I'm using. DC analysis approximation method. Assuming base current, assuming IB is negligible. Okay, so here no current is going, so this voltage will divide here and here. So VB will be what? VB will be 12 upon 90 plus 22. How much? 90 kilo ohm plus 22 kilo ohm into 22 kilo ohm. So 12 upon how much become 112 kilo ohm into 22 kilo ohm. This cancels out. Tell me what is the value of this one. This become how much? 24, 24, 26, and this is your 112. Tell me what is the value of VB. 2.3.
2.35 volts.
2.35 volt. Is that so? Let me check. Okay. Now find out what is the value of PE. What is the value of PE here? Assuming this is 0.7. Okay, 0.7. So what will become? PE will be, how much BE will be? BB minus BPE. BB minus BPE. BB is your 2.35 minus 0.7. How much is coming? Tell me. What is the value? 1.65. Yes or no?
Yes, sir. 1.65.
I don't have data because you tell correct value. Okay. Now you know the VE. Now you want IE. IE 1.65. This voltage divided by RE. RE is 1.5 kilo ohm. So how much milliampere is coming? Tell me. 1 point
1.1.
1.1.
1.
Okay. 1.1. I'm writing this one. Tell me if it's wrong. So 1.1 milliampere. Now you have IE. You can say IC is almost equal to 1.1 milliamps. Okay. Or you don't need IC. Basically, you need only IE. So now you have IE. So you want to now calculate RE. So RE is what? 26 millivolt upon IE. IE is your 1.1 milliamps. How much this coming? 25 ohm coming. Tell me approximately.
23.6.
43.6. 43.6 ohm. Okay. So and this is correct.
Yes, sir.
So now this is coming your 23.6 ohm is your RE. Okay. Now you have the value of RE. Now you don't require your DC analysis completed. Okay. Now replace this by AC, this circuit by AC equivalent. Okay, even you don't need to replace because now you remember. Okay, what should be the formula? Okay, but just one time I'm replacing this one. So so remember this value 23.6 ohm. Now the equivalent circuit will be what? For AC, you will have this VS, RS, then you will have it. You have to make this short circuit. Okay. So now you have a RS, R1, R2. Okay. And here, if I'm putting capacitor, okay. So one time we will solve with capacitor and one time without capacitor. Okay. One time capacitor is there, one time capacitor is not there. So now capacitor is there. So this approximation is with CE. Okay. This approximation method is with CE present. With CE present. Now C was present, so this becomes short circuit. So RE will be removed. So you will only have a beta RE. Okay. Your circuit is just here is you have a beta RE. And outside circle, this circuit here, you have a capacitor and you have a RL. Where? This side RL. So you have a RL is connected also ground with this one. This also. So you have here, this side you have a current beta IP coming, plus you have RC, plus you have RL. And R naught is not given, so you can take it infinite. So basically, this is your circuit, and now you want to find RCRL. I naught is coming from here. Okay, and this is your ground. Now your V input will be always here. Okay, not here. This here, your V input will be always here. This something will lose here. Something will lose in the internal resistance that we don't need to calculate. And if it's given also, you can apply KVL. If you want to consider also, then also you can calculate what is coming here basically. See, this is your value. This something will be lost here. Something will come here. Apply KVL, you can calculate here. Okay. Now, if I want the value of say what value of R input, tell me what is the formula for R input. Make it everything short. Okay. So this one, RS. So if RS is not given or a very high value is given, you can leave it out. Okay. Now this question RS is not given in the question, so you leave it out. So your R input will be only R1 parallel, R2 parallel, beta Re. This is the input resistance. Of course, you can conclude RS also, but RS is not given. Okay. RS value was given or not given? Tell me in the question. RS value was given or
Given,
not
sir.
given? Huh?
Given 1K. 1K was given.
1K, 1K. And put it 1K also. What is the problem? So I'll find the input resistance now. Input resistance will be what? Here is current is IB, I know. So I put it RS also. What is it? So RS is one. So R1 is 90 kilo, 90K. R2 is 22K. Beta RE is 23.6 and 100. So 2.36 kilo, 2.36 kilo. And now RS is 1 kilo. Tell me equivalent resistance. Tell me what is equivalent resistance. It will be less than 1 kilo. How much is coming? So 1 by 90, 1 by 22, 1 by 2, this is 1 upon 1 kilo. So I'm assuming this will come around 1 kilo. Now you tell me what is the exact value. You can do it. And the second will be your R naught. Second case, you will be having your output resistance. Output resistance, which is R naught, and R naught will be simply here parallel RC and RL combination. Parallel RC, parallel RL. What is the value of RC? 5 kilo ohm. And what is the value of RL? 1 kilo ohm. Tell me yes or no. What's the value?
Yes, sir. RL 1 kilo ohm.
Now you can find the R output value. What is the value of R output? It's coming 25.
सर आर इनपुट के पैरेलल वालों का आंसर 0.6 आ रहा
हाँ?
है आर
0.6.
इनपुट हाँ 0.6
Yes, sir. 0.6 आ रहा है.
ये हो गया 5 kilo ohm. Okay, 5 into 1. And this is 6. कितना आएगा? 5 by 6 kilo ohm. R naught. Now tell me what is voltage gain. Voltage gain is AV V naught upon V input. And we know what is the formula yesterday we have seen. V output is what? This beta IB into equivalent of this one. Beta IB on RC parallel RL current. And here the current is how much? V input. Here current is IB. Here current is IB. IB into beta RE. Beta cancel, IB cancel. So this will be given what? RC parallel RL upon RE. Now what is RC parallel RL? RC parallel RL R naught is 5 by 6 kilo ohm divided by 23.6 ohm. Tell me what is the value of gain? What's the value of gain?
0.035. 0.035.
ये 1000 भी तो है. So this is 1500.
3.5.
5000. 3.5 our answer. Huh?
Yes, sir.
Okay, this is 5000 divided by this is 6 into 24. How much? 6 into 24 is how much? Almost 144. How it will come 3 point something? 23 ohm ही था यहाँ पे.
35.29.
How much?
35.29.
29.
8.29.
Oh, this should come around
So not 40, sir. 35.29.
35. 35. This should be the answer. Value. Because if it is 150, 150, so this is 25, 150 and 5000. How much come when you do it this way? Okay, 5000 divided by 150. How much will come? 3, 3, 5.
Sir, 35.29. ठीक है, sir.
ठीक है. ये ऐसा बोलो ना. So this is with CE. Okay, voltage gain. Now calculate the current gain. How much is coming? What is the formula for current gain? Can anyone tell me? What is the formula for current gain? Current gain yesterday we have calculated AC I naught upon I input. Okay, and what was the value of I naught? Can anyone remember what is the formula here? Now here parallel RL is also there. So this is my I naught. Okay, so I naught will be what? If I total current is beta IB, total current is beta IB, resistance I will take opposite RL. Okay, and then I will take RC plus RL. This is my I naught. And now I input will be what? I input coming from here. Okay, I input will be divided here, here, here. So say this is R dash beta RE. Okay, so can I write IB R dash beta RE upon this is given R dash. This is the formula. Okay, IB cancel. Beta is 100 given. RL is given 1 kilo ohm. RC plus RC is given 5 kilo ohm. Plus RL is given 1 kilo ohm. It is given 6 kilo ohm. Okay, and then R dash will be how much? Tell me what is the value of R dash? Calculate the value of R dash and then put it the formula and tell me how much what is the answer is coming. 90 and 22. 90 and 22. So R dash will be 90 parallel 22 and this is 1112. What is the value of R dash in kilo ohm? Plus beta RE. Beta, this is 23.6. Okay, so multiply by 100. So it will 2.36 kilo ohm. So R dash plus 2.36. Tell me how much is coming.
Sir, R dash is 17.7.
17.7 kilo ohm. Okay. And 2.3 kilo ohm. This will you count 2.3 here. 18. So this will become almost 20 kilo ohm. This is 17 kilo, 17.7 kilo ohm. The sum is almost 20 kilo ohm. This cancels out. Okay. 1000. Now solve this value. Tell me how much is coming beta. I think it's not coming correct. RL is 1 kilo ohm. kilo cancel. So this become 1, 5. Tell me what is coming. Now you can solve this one. This is a calculation. Okay, you can do it yourself. I'm not doing this calculation because I don't have answer. So I will solve some whichever I answer. So we can check there. And now you have, so this you have done with CE. And if you do without CE, then here RE will also come into the picture. Okay, so that is your homework. You can do it. Now let me do some problem which I have answers. Remaining part is your homework because this is only calculation. Now you understand what is the method, so you can do it. Let's give you one. I'll do one more problem. So say I have this one. The value is say 56 kilo. So it's 12 volt. Here you have a RC. Here you have a 12 volt. Here you have R1, R2. RE. Here you have a V input. Six point eight, 1.5. 1.5 kilo. 6.8 kilo. And the value of R1 is 56 and 8.2. 56 and 8.2 kilo ohm. And this make it 22. Now solve this one. RE is 1.5 kilo. Everything is given, this given, this given, this given, this given. Okay, only beta value is what? Beta value is 90. Beta you take 90. Now solve. Find the R naught is infinite. R naught you can remove. So first you calculate RE first.
Sir, that VCC is 2.2 or 22?
22.
Okay.
So first, basically, you have to check beta RE should be greater than 10 R2. So this has become now 1500, and it is satisfied. So you can apply approximation method. Okay. Beta RE should be greater than equal to 10 R2. Okay. So this is beta. This is 100. Beta is 90 into RE is 1.5 kilo ohm. 10 R2 is 8.2 kilo ohm. Okay. So this is 82. Of course, this is a greater than 82. So this condition is satisfied. Okay. So you can use approximation method. Use approximation method. You can find the VB. VB is 22 divided by 50 kilo ohm plus 2.2 kilo ohm into 2.2 kilo ohm. And tell me what is the value of VB. I'm getting 2.81. Check it. Hmm.
My R2 is 8.2, sir. 8.2K.
Yes,
But you written 2.2K.
8.2. Check it now, it's coming or not. So 58.2 divided by 22 into 8.2. And once you know the VB, tell me VE. V will be VB minus VBE. 2.81 minus 0.7. It should be 2.11 volt. Check the value and tell me whether it's correct or not.
Sir, VB is coming 3.1.
3.1. Anyone else? How much is coming?
Yes, sir. 3.1.
VB is coming 3.1. Okay. So this is 50, na? Okay. Oh, actually it is 56. I have written 50. Okay. Then to make it 3.1, what is it? Okay. 3.1. And now this will come how much? 3.1 minus 0.7. How much will come? 2.4.
Yes, sir.
Now what is the value of IE? VE divided by 1 RE. 2.4 divided by RE is 1.5 kilo ohm. Tell me how much milliampere is coming? Approximately 1.5. How much is coming?
1.6 milliamp.
Yes, sir. 1.6.
1.6 milliamp. So now what is your value of RE? 26 millivolt and then 1.6 milliamp. How much is coming? 26 divided by 1.6.
1.625.
अरे भाई 26 divided by 1.6. 1.6 coming ना? कितना आएगा?
16.25.
16.25.
16.25. Now you know the RE. Okay. Now you can directly use the formulas and you can find the internal resistance, input resistance, RE, input resistance. Input resistance is what? Input resistance is this R1, R2, R1 parallel to R2, because here capacitor was there, so it will RE will be removed, so only it will come beta RE. Okay, and this is R dash, R dash, beta RE. R dash is R1 parallel. It's coming.
Sir,
Ah,
sir, did we consider C present there?
C was present. Huh?
Okay.
So it should come around 1 point. So RE is 16.25 and that is 1.6 kilo ohm. Okay, and R dash is your around 7 kilo ohm. So approximately it should come around 1.3 or 1.2. 1.3, how much coming? So R dash is basically 50 into 8.2 divided by 58.2 kilo ohm.
7.04.
7.04. So 7.04 kilo ohm. Okay. and beta, and this is your 1.625 kilo ohm. This is 7.04 kilo ohm parallel to beta Re 100 multiply, so 1.625 kilo ohm. Approximately how much will come? 1.3 or something.
सर अब बीटा की वैल्यू सर 90 है ना?
बीटा को 90, हाँ 90 है, तो फिर कम हो जाएगा, कितना आएगा? 1.5 किलो ओम कितना आएगा? Guys, 90 into 16.25 ohm.
सर ये तो सर 1.462 आ जाएगा सर किलो ओम, 90 से मल्टीप्लाई करेंगे तो
1.462
462 is parallel to 7.04.
ये वाला बोल रहे हैं 1.462.
Yes, sir.
1.462 kilo ohm, and this will come around how much? 7 into 1.462, which is 7, 8.
1.21 kilo ohm.
1.21 kilo. Okay. And now second is your R naught. How much is R naught is coming? R naught, there is only RC. RC is how much? RC is 6.8 kilo ohm. So R naught is only 6.8 kilo ohm. Nothing is there. Only RC is equal to RC. R naught is infinite. And now you have some gain. AB. AB is equal to minus RC upon RE. This is the formula. Beta IB. Beta IB cancel. This is RC upon RE. So RC is 6.8 kilo ohm and RE was 16.25 ohm. Whatever, you can check what is the value is there. Tell me what is the gain. In my, it will come, minus will also come. Okay. If it's a positive value, then you write positive value. How much is coming? It should come around approximately 400.
$418.4.
418.4. This is your answer. So you can do it. I'll do just one more problem from. So only one thing will be asked. It will not ask everything. Okay, only they will ask one parameter only. Like in the they asked in the GATE 2017. So you have R1, R2. Then here they say this is R3. This is your V input. This is your VCC. And the value is given, R1 is given 10 kilo ohm, R2 is given 10 kilo ohm, R3 is given 1 kilo ohm, beta is 99. They say find ZI, input impedance neglecting neglecting ammeter base junction resistance, neglecting ammeter base junction resistance. So what is ammeter base junction resistance? This is the ammeter base junction resistance, RE. RE is what? Ammeter base junction resistance. Okay, you have to neglect this one and you have to find ZI. And now the formula of ZI will be what? R1 parallel to R2 parallel to this you neglect. Only here beta R3 or exactly beta plus 1 R3. I generally we write beta R3, but exactly is beta 1 plus 1 R3. Solve this one, this will be your answer. I'll come in 1 minute. Let the values. How much is coming?
Sir, 4.76.
Yes. 4.76 kilo. Answer. So this is, we are stopping your register. Okay. If I find some good problem, we'll solve that one in YouTube. Now we'll starting our new chapter, operational amplifier, very important topic. Okay. How much time is with half an hour is there? Let us start operational amplifier. Now, if I see the symbol of operational amplifier, circuits, this is given by like this. Plus, minus, you have a 2 here, and this is your power supply. Okay. So these 5 terminals are very important terminals. Okay. For problem solving, we only need these 5 terminals, nothing else. So wherever this plus sign is there, this is called your non-inverting terminal. It's called non-inverting terminal. Whereas a minus sign is there, this is called your inverting terminal. Inverting terminal. Okay. Here you apply biasing plus VCC minus VCC, and here you get the output. So this is your output terminal. Now your operational amplifier is basically op-amp is basically is and is a basically op-amp is basically a difference amplifier. This is a difference amplifier. Okay. Now, what do you mean by it is a difference amplifier? Difference amplifier means if you apply V naught here, output, if you apply some voltage here, V plus, and here apply V minus. So the difference of these two is VD. Okay. So difference is VD is what? V plus minus V minus. Okay. That is input at input. V plus is what? V plus is input voltage at non-inverting terminal. Non-inverting terminal. And V minus is what? Input voltage at inverting terminal. And the difference of these is given by VD plus V naught. So whenever you apply difference at the input, you will get an output which will be gain multiplied by, let's say you say VID, input difference, VID, okay, where AOL is what? AOL is open loop gain. It's an open loop gain. And VID is what? VID is the difference of input voltage. Difference at input voltage. Now this AOL is very high. Okay. So it is a difference amplifier. Whatever difference you apply here, say you apply 10 millivolt here, 9 millivolt here, difference is 1 millivolt. 1 millivolt will be multiplied by the gain, whatever gain is the circuit, and you will get accordingly the output. Okay. Now it is also called operational amplifier. Okay. It is why it is called operational amplifier. It is called an operational amplifier because it can perform many mathematical operations such as analog inputs को add करना है, subtract करना है, we can perform using op-amp. Okay, so it can perform mathematical operations such as addition, subtraction, differentiation. If I want to differentiate input, I can differentiate output. Output can be the differentiation of input. Differentiation, integration, and integration, etc. Extra. So we can do many mathematical applications. That's the name, operational amplifier. You can do many operations. Okay, like you can rectify small signals with using. Okay, you can use it as a filter. You can high frequency filter, low frequency filter. So it can perform many operations इसीलिए इसको बोलते हैं ऑपरेशन एम्पलीफायर। और काम कैसे करता है? काम ये करता है, whatever you apply difference, the difference it will amplify, okay, which it is gain, open loop gain. So this is your open loop gain. So here you will apply input, here you will apply output. Now what is the use of this one? Okay, this is the biasing. Now if you are applying 1 microvolt here, suppose the open loop gain is 10 raised to power 6. Okay, then what will be the V output? For example, if I say open loop gain is very high, so I am assuming my AOL is say 1 microvolt. Sorry, AOL is 10 raised to power 6. It's very high. Is generally it is order in the, it is order I'm writing here. Order is 10 raised to power 4 to 10 raised to power 6. It can be 10 raised to power 3 also, some lower value also, but generally it is very high. Now for just for understanding, I am telling my AOL is 10 raised to power 6. And I'm applying a 1 microvolt difference here. What will be the my V output? बताइए अभी.
Sir, 1 volt.
1 volt, very good. So I'm erasing. Can I erase this one, Karishma? Deepak?
Sir, I have done, sir.
So whatever difference you apply, okay, you can gain. So let us understand how does it work. Say I want to draw V output versus V difference curve. Difference can be negative, difference can be positive. It's a positive difference. Here VID is positive. This side your VID, if VID is negative. Okay. So now let us calculate the curve. To understand, this is called output versus input. This is called transfer curve. Okay. This is called your transfer curve. Now I'm saying that AOL is 10 raised to power 6 and my VID is difference of here. I'm applying 2 microvolt here, 1 microvolt here. VID is V plus minus V minus is say 1 microvolt. Okay. So VID is 1 microvolt. Okay. I'm getting V output will be 10 raised to power 6. V output is what?
1
AOL
volt.
VID, that is 1 volt. If VID is say 5 microvolt, my V naught will be 5 volt. Okay. And now say VCC is say 10 volt. This is a 10 volt. VCC is 10 volt. VCC plus is 10 volt. VCC plus is 10 plus 10 volt. And this is a minus 10 volt here, this one. Now difference I'm applying my 5 microvolt, I'm getting 5 volt. Okay. So that if I applying 6 volt, I get 6 volt, I get 7, I get 7, I get 8, I get 8. That is a linear relation. VID versus V naught is a linear relation. Now what about if I apply difference VID is 10 microvolt? What will the output?
10 volt.
10 volt, very good. Now second time if I applying VID, now say I'm applying 11 microvolt. What will the V output? Tell me now.
Again, it is 11 volt.
11 volt.
It will be 10 volt.
10 volt. It cannot be 11 volt. Because how this is the energy conservation. Maximum output you can get across to the equal to the VCC. whenever your input is such input value is such that this value multiplied by gain becomes higher than the VCC, applied VCC. So your output will become 10. Now you apply 12 microvolt difference, it will be 10, 13, 10. So your output will saturate. So now your curve will come like this. It will saturate to VCC. That
सर
is,
इज इट पॉसिबल कि ये दोनों तरफ का जो VCC वैल्यू है वो दोनों डिफरेंट हो सकता है जैसे
हाँ, दोनों डिफरेंस हो सकता है. Both can be different also. It can be 10, it can be 5. That both possible. And even though I am putting here that maximum voltage you're getting VCC, but actually you get somewhat less than VCC, okay? Because some loss will be there, na? You cannot apply something and you cannot get an infinite gain. You cannot
सर
get infinite gain. हाँ.
वैसे कंडीशन में कौन सी VCC का वो सैचुरेशन वैल्यू पकड़ेंगे 10 वोल्ट और 5 वोल्ट
अगर प्लस में पकड़ रहे हो तो प्लस का, माइनस से पकड़ रहे हो तो माइनस का. अगर डिफरेंस माइनस है तो
ओके सर
okay.
ओके
So this VCCs can be different also. You can put it, say this is VCC1, you can put it VCC2. Now value may be different. Okay. So they say this is VCC1, you can value may be different. Now similarly, if difference is negative, here you apply higher voltage, here low voltage, same thing will happen like this, and your difference will come. It will saturate here minus VCC2. Value can be same or value can be different. Here I am putting the same value. So this is the transfer curve for a practical op-amp. Transfer curve for practical op-amp. Gain can be 10 raised to power, say anything. You apply millivolt also. I'm just applying smaller voltage volt micro millivolt. You apply, if you apply millivolt difference, then automatically it will get saturate. Okay, so this is the practical op-amp. For some time you're getting linear curve, then it gets saturate. Now if you apply say 1 millivolt difference, then what will happen? What is the output? If you apply 1 millivolt difference, what will the output?
सर तो 10⁻6 ही है सर.
हाँ, 10/60 है.
1000 वोल्ट हो जाएगा फिर तो.
1000 वोल्ट आएगा क्या?
सर 10 वोल्ट ही आएगा 10 वोल्ट ही
10 वोल्ट ही
10
आएगा.
वोल्ट
10 वोल्ट ही आएगा. तो अभी ये जो लाइन दिख रहा है, अगर ये डिफरेंस इसको अगर मैं ये तो मैंने ये माइक्रो वोल्ट में, ये माइक्रो वोल्ट में, अगर इसको इसी कर्व को मैं मिली वोल्ट में स्केल कर दूं तो ये पोर्शन भी दिखेगा ही नहीं हमको. दिखेगा क्या? दिस विल बिकम वेरी स्मॉलर स्मॉलर स्मॉलर. Similarly, this scale is volt, so microvolt I cannot see. So generally, whenever your gain is very high, I plot this is for practical, okay, for just for understanding. Generally, when we see op-amp transfer curve, that is plotted like this. This is your VID, this is your V naught, because the AOL is considered infinite. So infinite का मतलब क्या है? You apply anything, any difference you'll apply, the output will come infinite. Infinite cannot come, so it will saturate to the base, to saturate to the VCC's value. So this is actually, this is for practical. Gain can be 10 to the power 3, 4, 5, 100, 80. This will come. But if gain is infinite, which is the op-amp, ideal op-amp, then anything you apply, kuch bhi you apply, it will saturate. Or suppose this is a millivolt scale, and you're applying difference in microvolt, and it will come like this here, and it will saturate. So that will not be visible. Are you understanding now everything what I am saying in the language? Okay, understanding you cannot express beyond a level. Okay, language you should understand what I'm trying to say. Okay, so if difference is very small, then you can get this kind of curve. But otherwise, if gain is very high or difference is 1 millivolt, 2 millivolt, even 10 microvolt, then everything depends on the scale how I'm plotting. So generally, your ideal transfer curve are plotted like this. This is your ideal op-amp. And if you want to further understand, you can say ideal op-amp open loop gain is infinite. So anything you can apply, it will saturate. So this is the ideal op-amp transfer curve. This is number 1 point. So first I told this is a difference amplifier, number 1 point. It will give you V output equal to AOL VID. Second point I told you about their transfer curve. Okay, and transfer curve originated from the here saturation property. Number 2 property first is difference amplifier. That is V naught is equal to VID AOL. Second point, it follows saturation property. That this V naught are always greater than plus VCC2 minus VCC, or VC, you can do VCC2, VCC1. Output cannot be greater than these value. This is called a saturation property of op-amp. Okay, this is the second thing while doing problems you have to understand. Okay, and now I'll talk about a third thing.
एक्सक्यूज मी सर
हाँ,
सर जो VID है सर उसकी वैल्यू सर मतलब टेंस टू 0 ही मतलब उसके कंपेयर में सर बहुत कम होगा ना, इसीलिए सर ये y एक्सिस के साथ साथ ही है ना सर।
ये वाला ना, हाँ बी
हाँ।
गेन पर जाता है। अब ये इसके सपोज मैंने वोल्ट में खींचा है और डिफरेंस तो माइक्रो वोल्ट में लगाया है, तो फिर वो
हाँ सर।
माइक्रो वोल्ट यहाँ पे कैसे दिखाऊंगा?
हाँ सर, बहुत ही कम होगा
हाँ,
इसीलिए सर।
बहुत ही कम होगा।
हाँ।
This is very small. It will come
हाँ
to
सर।
very small thing. That will, so it will look like this only.
यस सर, यस सर।
Okay, so this is ideal. And either you say like this or you say it is very high, infinite. Okay, almost
Yes, sir.
it will be like this. A 10 to the power 6 also is infinite only. Okay, 10 to the 6 5 is also considered is very high, at almost equal to infinite. Okay,
यस सर।
is there any question? Now, this is the property. Okay, so difference is negative, output is negative. Difference is positive, output is positive. The second thing is you have here op-amp plus minus. If you make this is ground and you apply some input here, say sine wave. Okay, now this, if you take the output here V naught, this will get amplify, and you get amplify. Say this is the 1 millivolt, it may be 1 volt. Okay, depending on what is the peak to peak value. Say it is 1 millivolt, and here it becomes 1 volt. Okay, so whenever you'll apply, making this ground, whenever you apply input the positive terminal, your input and output will be in same phase. Okay, so no change in phase, because difference is positive, so you apply positive, you get positive. Difference is negative, you apply and you get negative output. So your phase will not change. That's why this is called non-inverting terminal. So this is called, why it is called non-inverting, means it is not inverting your phase of the signal. Non-inverting terminal. It's a non-inverting terminal. And similarly, if I apply plus minus, say plus here, minus here, if I ground minus, if I apply here, say same 1 millivolt. Okay, here I'll get this one. So output will be like this, because difference is negative, output is negative. Difference is positive, minus terminal is there, so this will be negative always. When you apply negative something, this will become positive. So the output will invert. So this is 1 volt. So this is called your Inverting, that's why it is called inverting terminal. Okay. So that you to understand some things to learn. Now, with this small information, okay, I can treat one problem which is came in your exam. Not we'll do some properties, other properties tomorrow. But so here, 180-degree change of phase. 180-degree change of phase of signal, output to input signal. Okay. Now say you have a op-amp plus minus plus 10 volt minus 10 volt. You're applying some resistors there. Sorry. Here, some resistor is there. V input is there. This is 4 kilo ohm and this is a 1 kilo ohm. Here I'm applying 5 volt. Okay. And here I'm applying some V input. Now you have to tell me what is the transfer curve for this one. So input, okay. So I'm giving the input, you have to tell me what is the output. So this is my input. This is my V input curve. Okay. So say it is increasing, say it is going, say this is 5 volt. Okay. It's going 5, 10, this is giving 0, 1, 2, 3, 4, 5. It is going like this. V input. And I want to find what is my V output for V input. V input is positive only. This is with time. Okay, time scale. My input is changing from 0, 1, 2, 3, 4, 5. But tell me what is the output? Tell me. Can anyone tell me what is the how should I do the problem? How should I approach the problem?
So is it 10 volt?
So now this is V plus. V input is I'm applying some input here. This is my V plus. Okay. So my V output will be what? V output will be always V plus minus V minus into AOL. Okay, that will be the value. And now AOL is infinite. This is ideal. This is ideal op-amp. So you can assume AOL is, sorry, AOL value is given or not given? So this is ideal op-amp. So AOL is infinite. Okay. Now, whenever it is an ideal op-amp, your output will be what? Either like this or like this. Yes or no?
Yes, sir.
Yes. So your output can be only like this. So now this is your V plus. Now what is the value of V minus? Tell me. What is the value of V minus? What is the value of V minus? What is the value of V minus? Tell me.
1 volt.
1 volt. Very good. So this is 5 divided by 4 kilo. Okay, 4 kilo. Here no current will go. I will discuss this one. No current will go here. I minus is 0, I plus is 0. Inside the op-amp, no current goes. That should be, I should have discussed first. Okay, tomorrow I'll discuss. So whatever current will come here, it will come here. Okay. So this is 5, this is 4 kilo ohm plus total is 1 kilo ohm into 1 kilo ohm. So this will come 1 volt. Okay. And now V input is changing. So whenever V input is greater than 1 volt, I will get V output equals to how much? If V input is greater than 1 volt, I'll get output equals to V output equals to plus VCC 10 volt. And whenever V input is less than 1 volt, because output will always saturate for ideal case, either will go high or it will go low. If V input is less than 1 volt, then I guess a minus VCC, V equal to minus 10 volt. So V input is 1 volt here. This is the V input 1 volt here. So whenever V input is less than 1 volt, because V minus 1, I'll get the output equal to minus VCC is my V output minus 10 volt. After this point, it will become greater than 1 volt. So after that, I'll get up to say here, I'm plotting, say here, I'll get this one. Here, I don't need, suppose up to here, I'm plotting. So after this range, my input become greater than 1 volt. This is fixed 1 volt. And I'll compare with this one. If this is greater than this one, you get this one. If this is less than this one, you get this one. So initially up to here, this part, this is less than this one. So you're getting this one. After this part is being greater than this one. So this is your output characteristics V naught. Now, if anybody doesn't understand, इसको समझ में नहीं आया हो तो बताओ. I'll discuss it once again. Leo, Deepak,
Yes, sir. Yes, sir. Understood.
Kashish.
Got it.
Sir, can you explain again?
Again. So here the voltage is, I'm applying 5 volt. This is a 4, 1. Here voltage is what? 1 volt. That is input terminal volt. This voltage is when 1 volt is coming. So whenever this voltage is greater than this volt, your output will get saturated because V naught output will always saturate in this case, either to positive or negative. That is the property of op-amp. You will get this one or this one. This one will get, whenever this is greater than this one, you get this one. Whenever this is less than this one, you get the minus one. So now input is varying like this, 0, 0, this is going 0 to 5. So this time, in this time period, my V input is less than my V plus is less than V minus. So this period, I'll get this one. And after this period, it is become greater than 1 volt. So I'll get the plus 10 VCC. Clear?
Yes, sir.
Okay. So let us stop here, and tomorrow we'll discuss more property and then we'll do the op-amp. Okay. Thank you.